Okay, so good afternoon, everyone. Once again, everybody hearing me?
Yes, sir.
Yes, sir.
Okay, so welcome to our final Sunday class. I'm sure you all are very happy. So in today's class, we're going to be looking at linear programming, right? Now, linear programming is a technique that is used in mathematics to solve problems involving maximizing and minimizing linear functions when several constraints are to be considered. So it is usually associated with optimizing costs in production. So let's get straight into the lesson, right? The general process of solving linear programming problems involves the graphing of a set of inequalities. So your prerequisite knowledge for this class would have been inequalities. If you do not understand inequalities, because I remember when I taught you all inequalities, I told you all that you all will be using your knowledge on inequalities in a topic called linear programming. This is the topic I'm talking about, right? So you would have had to understand inequalities in great detail to be able to know how to do this particular topic, right? So the general process for solving linear programming problems involves graphing up a set of inequalities called constraints, obtaining a region that is common to all, which is referred to as the feasible region, and then applying the fundamental theorem of linear programming to determine the optimum solution. So this is just giving you an idea of inequalities more or less. Now I want you all to remember that when we have a sign that looks like this, which is greater than, notice it's greater than, it's not greater than or equal to. Remember when it's either greater than or less than, the circle is drawn as an open circle, so it's not shaded, right? If it was greater than or equal to, then it would have been a shaded circle. You all remember that when we did inequalities?
Yes, sir.
All right. So of course, in this case, x is less than or equal to 5. So as you can see, it's a closed or shaded circle. You follow? You guys, you hear me? You all following?
Yes.
Yes.
Okay, so let's look at what I would have meant if I just gave you all these alone. So x is greater than 4. That means that, as you can see, it's not equal to 4, so we do not include 4. So that means that x will be things like 5, 6, 7, up until infinity, right? S is less than or equal to 5. That means that x includes 5 and values less than 5. So 5, 4, 3, 2, 1, etc. You all following?
Yes, sir.
All right.
Yes, sir.
So let's look at linear inequations on the Cartesian plane. So we will first examine the special cases when the straight line is vertical or horizontal. So let's look at vertical lines. A vertical line has a general equation, x is equal to 0. Just a minute, I'm seeing somebody chatting. Oh, no problem, David. So a vertical line has a general equation, x is equal to a, and cuts the horizontal axis at e. For example, when a is equal to 3, the line cuts the x-axis at 3. So again, x is equal to a. So if a is equal to 3, that means it cuts the x-axis at 3, where x is 3, positive 3 that is, you will draw a solid line coming across. Everybody okay with that?
Yes, sir.
Okay. And all points on the line have the coordinate of 3. As such, we have 3, negative 3, 3, negative 2, 3, negative 1, 3, 0, 3, 1, 3, 2, 3, 3, etc. You notice the x coordinate in all of them they are beginning with 3, right? Are you all seeing that?
Yes.
Right? So the region to the right side of the vertical line, so x is equal to 3 is this straight solid line here, right? This is the x-axis. The horizontal axis is called the x-axis. So you will find x is equal to 3 here, and you draw a straight line here, right? This is x is equal to 3. This region on the right-hand side here represents the values where x is greater than 3. And this region here represents the values where x is less than 3. Making sense? People?
Yes,
Yes,
sir.
sir.
All right. Let's look now at horizontal lines. So if vertical lines were on the x-axis, what do you all think? Where do you all think horizontal lines will be?
The y-axis.
Correct, on the y-axis. So a horizontal line has a general equation, y is equal to b, and cuts the vertical axis at b. For example, when b is equal to 3, that means that the line cuts the y-axis at positive 3. So therefore, all the points in the coordinates will have 3. So as you can see, we have -2, 3, -1, 3, 0, 3, 1, 3, 2, 3, 3, 3, etc. The y coordinate in this case is 3. So let me put it into context for you all. As you all can see, we have 1, 2, 3, 4, 5, and 3 is on the y-axis here. So we draw the line over here, a horizontal line, y is equal to 3. This region here represents y is greater than 3. So this will represent all the values up here. And when y is less than 3, it will represent all of the values to the bottom here. Any questions?
No, sir.
Okay, what does this simply mean? This means that if we say x is 1, if x is 1, what is the value of y?
3.
It will always be 3. If x is 2, what is the value of y?
3.
If x is 5, what is the value of y?
3. 3.
If x is -2, what is the value of y?
3.
Right? That is what all of this in the brackets here mean. Okay? And the same would have applied to the x coordinate. No matter what y value you choose, whether it's +2, x will always be 3. If it's -2, x will be 3. That's what these coordinates here in the brackets meant. Okay, I forgot to say that when I was here. Everybody cool so far?
Yeah.
Yes, sir.
Right, so that is only if we're dealing with horizontal and vertical lines. Now, based on our knowledge on coordinate geometry, we know that there are lines that have a slope, right? So they will therefore have the equation y is equal to mx plus c. So you all remember this equation with the coordinate geometry?
Yes.
So, right, so lines whose equations are of the form y is equal to mx plus c. When a line of the form y is equal to mx plus c is drawn on a Cartesian plane, it divides the plane into two areas or regions. One satisfies the region y is greater than mx plus c, and the other one satisfies the region y is less than mx plus c. So remember when we were doing these here, it was also satisfying two regions, y greater than 3 and y less than 3. You all remember that? We just did that there. So now, when we are dealing with the equation of a line, y will be greater than mx plus c, and the next one, y will be less than mx plus c. Any questions there so far?
No, sir. No, sir.
All
No,
right.
sir.
So to represent the region that satisfies an equation that would look something like this, we carry out the following steps. The first thing you would want to do is create a table of values, and you're also supposed to know how to create a table of values because I taught you all how to do graphs, right? Create a table of values to include at least 2 points on the y is equal to 2x plus 3 line. You choose any of the x values and substitute them into the equation, and you will obtain a corresponding y value. So you construct a table of values, right? Let me show you all something. Right. So you can construct a table of values. And as you all know, we have an x coordinate, a y coordinate, right? So we can choose 2 or more values. The handout says 2, but we can choose any amount that we want, right? So let's just choose 2 random values. Let's say we choose -4, and let's say we choose 2. And the equation was y is equal to 2x plus 3. So we'll substitute this to get our y value. So y is equal to 2 into -4 plus 3. 2 by -4 is -8 plus 3. -8 plus 3 will give us -5. When the signs are different, you find the difference and you keep the sign of the greater number, right? y is equal to 2x plus 3. Y is equal to 2, when x is 2 now, into 2 plus 3. So y is equal to 4 plus 3. Y is equal to 7. So we have 7 and we have negative 5 here, right? Now you could have chosen any two values that you wanted, right? So let me just quickly switch back to the table, but let me just explain how they got that for you first. So I'm just quickly erasing this, right? The actual question, they selected for the values of x, they selected 0 and negative 1. Okay, so y is equal to 2x plus 3. When x is 0, y is equal to 2 into 0 plus 3. Y is equal to 0 plus 3. Y is equal to 3. So 3 goes here. Next one, when y is equal to, sorry, when x is equal to 1, y is equal to 2x plus 3. Y is equal to 2 into 1 plus 3, because the value of x in this case is 1. So y is equal to 2 plus 3. Y, oh no, sorry, they use negative 1. My apologies. So this will give us negative 2. And again, the signs are different. When the signs are different, you find the difference. So the difference here is 1, and you keep the sign of the greater number, so it's positive 1. So 3 and 1 becomes our answer. But again, you could have chosen any two values of x. You didn't have to choose negative. You didn't have to choose negative 1 and 0. You all following?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Just a minute. I just accidentally clicked something on my screen and it opened. Oh Lord, not now, not now, not now. Oh, really now? Really? Way boy. Are you all hearing me?
Yes,
Yes,
sir.
Yeah, my laptop just froze on me. Like,
Hello.
okay, so here's what we're gonna have to do. We have to go old school for now, right? Are you all see my camera on?
Yeah. Yeah, we are.
Is it like on the screen? Okay, great.
I can see your hand.
All right. I don't know why this is happening, but we're gonna have to do that. Can you all see it? Oh dear Lord. Okay, wait. Close program.
Sir, why is this the dude from your phone?
Is this better now? You all hear me, right?
Yep.
Okay, great. Let me see if I can. What? I'm not the host now?
No, the computer that crashed was the host.
Just a minute.
It still shows you as the host and it's still recording. It's just that you're me.
Okay, great, right. So right, we were over here, creating the table of values. Oh my God, it's sticking again.
Pass.
Okay, so we were here. Let's continue. Just a minute, I'm seeing somebody messaging. Okay, all right, great, yeah. So let's continue. The second step is to plot the points and join them to form a straight line. The line may be extended in either direction to any desired length. So we would have plotted the points. So the values you would have gotten would have been 0, 3, and negative 1, 1, right? So when x is 0, y is 3, that's this point here. And then when x was negative 1, sorry, when x was positive, no, when x was negative 1, y was positive 1, so that would have been right here, at this point here. You all follow?
Yep.
Yes, sir.
Okay, so then you would have just taken your ruler and connected the line, and let it cut the axis, and you would have gotten the straight line here. Now the third step is to locate the region on both sides of the line. One is the region y is greater than 2x plus 3, and the other is the region y is less than 2x plus 3. We may label the regions A and B for easy reference. So this side we're calling it A, this side we're calling it B. Everybody following? Anybody confused so far? Say no. Okay, so again, for ease of reference, we are calling this side A and this side B because we do not know which side of this red line satisfies the equation or the inequality. So in locating the desired region in step 3, we choose a point either in region A or in region B to test if the point lies in the region. Now I want you all to know how to do this test, right? If the inequality is satisfied in this region chosen, if the inequality is satisfied, then this region chosen is the desired region. If not, then the other regions satisfy the inequality. So the test point is 0, 0. Okay, this is called a test point. So we will look at, I'm going to redo this table using my camera, right? So remember, we are using the test points 0, 0. Everybody good? Region A, and we have region B. And we are using the equation, the inequality y is less than 2x plus 3. Okay, so remember this is the x value and this is the y value. So y is 0 is less than 2 into 0 plus 3. Anybody confused there? What am I doing? I'm just substituting. So 0 is less than 2 by 0 is what? 0 plus 3. And of course, 0 plus 3 is 3. Is 0 less than 3? That's what this is saying. 0 is less than 3. Is it true or not? Is 0 less than 3 or is 0 more than 3?
Less than.
Correct. So this is true. Let's test this region here now. 0 less than 2 into 0 plus 3. 0. Oh, sorry, my apologies. For region B, we have to choose a different, this is for region A, right? And region B, we choose any testing point. You follow?
Yes,
Hello.
sir.
So let's say we choose, well, in the handout, they chose -1 and 2. So let's use it as well. So -1 and 2. You can choose any point along that side, right? So y is 2 and -1. So 2 is less than 2 by -1 is -2 plus 3. And of course, 2, well, -2 plus 3, when the signs are different, you find the difference, which is 1, and you keep the sign of the greater number. Is 2 less than +1? Is 2 less than 1?
No.
No, sir.
No. So therefore, this is false. So the region that satisfies the inequality is region A. So let's go back to the camera, to the handout now. If somebody messages on the chat and it's important, can somebody just tell me, please? Because how I'm moving back from my phone to my laptop, it's difficult to read the chat, right? Okay, so our tests indicate that the point 0, 0, which lies in region A, satisfies the inequality. Note, all other points in the region A would have satisfied the inequality as well. So our test of the point -1, 2 in region B revealed that it did not satisfy the inequality because remember we found it to be false. Okay, so the side that we will be shading is the side with region A. So we'll be shading on this side here. You all seeing? So let me show you how it would look if we're shading it. So we're shading region A. Any questions so far?
No, sir.
No,
All
sir.
right. Oh God, what happened there, boy? All right. Conventions in drawing lines. So in the convention followed in this chapter, the solution of inequalities of the form y is greater than or equal to mx plus c and y is less than or equal to mx plus c are drawn as solid lines to indicate that such lines include all points on the line y is equal to mx plus c. The solution of the inequalities of the form y is greater than mx plus c and y is less than mx plus c are drawn as broken lines to indicate that such lines do not include the point on the line y is equal to mx plus c. Now remember when we did inequalities, I was telling you all if it's greater than or equal to or less than or equal to, we draw a shaded circle on the number line. You all remember that?
Tomorrow
Yes,
and
sir.
let her take everything
Right.
away
That
from
would be applicable for this here. If it's greater than or less than, it's drawn as a solid line here, as you can see here. However, if it's like this, greater than or just less than, it's drawn, as you can see here with this broken line, it's drawn as a broken line here. Any questions?
No.
Okay. So we shall now apply the above steps and conventions to identify the region for y is greater than 2x. So we create a table of values for the line y is equal to 2x. So when we have our x and we have our y value. So they randomly chose two values, 0 and 2. And obviously 0 multiplied by 2 will give us 0, hence the reason we have 0 on the y-axis. And if x is 2, then 2 by 2 will give us 4, and that's why I got 4 on the y-axis. Sorry, for the y values here. Everybody cool?
Yes, sir.
All right, the next step is to plot the points and draw the line. So the first point will be 0, 0, that's the center, and then 2, 4. Let's see. So as you can see, 0, 0 is the center, and then when x is 2, y is 4, so that would have been somewhere up here. All right, but remember it's not drawn to scale or anything of the sort. So we draw our line over here, and the final step is to determine which side we are shading. So we call this side A and we call this side B. Always try to call the right side A, right? So call this side A and this side B. The third step is to locate two regions on both sides of the line and label them as A and B. And since the point 0, 0, lies on the line, we cannot choose it for testing. You all hear that, right? This graph, the line passes through the point 0, 0. Remember, we were using 0, 0 as a test point. But since it passes through this point 0, 0, we cannot use it as a test point. So we have to choose two other values. Everybody okay with that? As you all can see in this one here, it did not pass through the test point 0, 0. But as long as it passes through the test point 0, 0, we cannot use it. So we can use any other points along the line. So in region A, we can choose 2, 0. And in region B, we can choose -2 and 0 as well. So we substitute these values into our equation. So when x is 2, y is 0. So we get 0 is greater than 4. And that is false because 0 is not greater than 4. We have region B. We're using the points -2 and 0. And remember the equation is y is greater than 2x. So y is 0, so you put 0 here. And then we know x is -2, so you substitute -2 here. So 2 by -2 is -4. So 0 is greater than -4, so this is true. So we know the inequality, sorry, the side that is satisfied is region B by the inequality. Okay, so let's see which side we'll be shading. Remember, it's a broken line because it's greater than we are using. As the sign here, we're using greater than. So it's a broken line here, and we are shading region B. Anybody have any questions or
No,
concerns?
sir.
Everybody
No.
understanding? I'll show any questions?
No.
Okay, I'll
No,
show
sir.
understanding it, right? Are you understanding it?
Yeah.
Yes, sir.
Okay, we'll say yes, and I'll just say not for me to finish it. All right, so let's look at an alternative method to identify the region that satisfies a linear inequality. Just give me 1 minute, please. Okay, right. So this is the alternative method. So a rather simple method that always works in identifying the wanted region in solving an inequality is explained below. So the first step, you draw the line which divides the X and Y plane into two regions, say A and B. That's this red line that we were talking about earlier on. Next, you draw any horizontal line to cut the line. So when you draw your curve, as is the red line here with the previous diagram that we were doing, you just draw any horizontal line that cuts that particular line. The third step is to determine the region that, thirdly, the region that contains the acute angle is the less than region. And the region that holds the obtuse angle is the greater than region. So this would have been the line, the graph, right? And you just draw any horizontal line. And this side here, whichever side has the acute angle, that's the less than region, and whichever side has the obtuse angle, that's the greater than region. This is quite simple, right? Agreed? Yes, no?
Yes, sir.
For anybody who was confused what I'm talking about, let me select, let's say this graph here. So let me do it on Paint for you, Microsoft Paint, and see if it will make sense for you, right? For you guys. Okay, so this is the graph. Let's say we wanted to determine which is the less than and the greater than region. We could have drawn a line here, right? Pay attention to the orange line here, this first orange line here. So as you all can clearly see, which side is the obtuse angle, the right hand side or the left hand side? People, which side is the less than region? The right hand side, region A, or less than, or region B?
So it look like A. No, B.
Yes. No, A is the less than region. Because this line here is the line I'm talking about now. So this here is the acute angle. So this is the less than region. And this region here is the obtuse angle region. So this is the greater than region. It making sense what I'm talking about now?
Yeah.
All right.
Yes, sir.
Okay, so conventions in drawing. Oh, we did this already. All right, let's look at an example here. Identify the region y is greater than -3 plus 4. So let me go to my camera. So let me just rewrite this. Y is greater than or equal to negative 3x plus 4. Okay? Anybody can recall what is the first step that we would take? What is the very first step?
Substitute the number for x.
There's something we have to draw first. I'll give you the acronym for it, TOV.
Table of variables.
No.
Ah.
Come on. This is the best letter of the English alphabet. You'll have
Table of
to.
variations.
What's that?
Table of variations.
Oh, good. All you want to give me half back here? Table of variations and thing, boy. Way. No.
Nani?
Let's play a game of hangman.
Table of values?
Yes, finally, oh gosh. Jeez,
I said that though.
All right, Sanjay, don't shout too much. I have on a headset.
Sorry, it's just my mic volume on.
So we remember we choose any amount of values, right? Let's just choose 3 values. So we can choose, well, I'll use what I have in the note, right? 0, 1, and I'll choose the next one. Let's say 3. So when x is equal to 0, let's see what y will be. Y is greater than or equal to negative 3x plus 4. Y is greater than or equal to negative 3 into 0 plus 4. Y is greater than or equal to 0 plus 4. So y is greater than or equal to 4. So we put 4 here. So that's our first set of coordinates, right? Let me take up the lights. Yeah, that's our first set of coordinates. Next, when x is equal to 1, y is greater than or equal to negative 3x plus 4. Y is greater than or equal to negative 3 into 1 plus 4. Y is greater than or equal to negative 3 into 1 is negative 3 plus 4. Y is greater than or equal to, so when the signs are different, what do? We find a difference, which is 1, and we keep the sign of the greater number. So the answer we are taking is positive 1, right? Can you all do the other one and tell me what's the answer? When x is 3, I want you all to work it out and tell me. I'll give you all 3 minutes for that.
-5.
Probably not.
So is -5.
Probably.
Sir?
Uh-huh.
Oh, my mic wasn't working all the time, and I had some things that wasn't that they explained, and I was trying to say no, sir. Explain it over, and he wasn't hearing me at all.
Oh, shucks. Well, you can raise up your hand.
I didn't realize it wasn't working. Okay, sir.
Oh, okay, okay.
Can I raise up your hand?
What?
Oh, no, sir. I harassed Alicia. That's anyway.
Oh. Okay, so can we correct then? I guess that's a yes. So let's see. Oh, what's his first step? Oh God. y is greater than or equal to, oh what, no, sorry. When x is equal to 3, y is greater than or equal to negative 3 plus 4. Y is greater than or equal to negative 3 into 3 plus 4. Y is greater than or equal to negative 3 by 3 is negative 9 plus 4. Y is greater than or equal to, the difference between 9 and 4 is 5, and we keep beside the greater number. You always say negative 5 over 5. Oh, David, I'm now seeing your responses. And you as well, Amit.
And me, I tell you it was -5 anytime I know.
Sorry, I didn't hear you. I don't recall that. I didn't
You
even
do?
hear you.
Okay.
Who are you? Who is this? Who am I speaking with?
I don't know. Yeah, I don't know.
Oh, neither me.
So we are
Okay.
getting values for x1 and 3.
Yes?
Yeah.
Oh, I just randomly choose values. You can randomly choose values for your x coordinates and get the corresponding y values. You don't have to get specific values. You can just choose any values for x. You can even choose negative values as well if you so desire. You will still obtain the same answer.
Oh, okay.
Yeah. It really doesn't matter which values for x you choose. Once you get the corresponding y values, the graph will take the same form as somebody who choosing different x values than you. So don't worry too much about choosing x values. I just choose 0 and 1 because the note had 0 and 1. So I was just showing you all how they got 4 and how they got 1 because it wasn't explained in the handout, right? But I just chose a random value again. I chose 3 and we generated -5. It wouldn't make a difference in terms of how the line is drawn. It would still pass through this point as well. All right?
Yes, sir.
So let's see now the handout. Right. Now, to save time, we will not be drawing anything, right? Although you should practice, but as you all know, you all are writing a multiple choice exam, so you don't have to draw any graphs, right? So the point 0 on the x-axis and 4 on the y-axis will be represented right here. Let me just snip this and put it on Microsoft Paint, and you all will be able to see it better. All right, so the point 0 and 4 will be right here. Let me just write our coordinates, right? It was when x is 0, y was 4. That was our first coordinate. Next coordinate, when x is 1, y was 1. And the last coordinate, when x was 3, y was -5. Okay? So now when x is +1, y is also +1. That's along this line here. And when x is +3, y would have been -5. So that would have been somewhere quite down here. 3 and then 5 would have been somewhere down here, right? So it would have still passed through the line. The line would have still passed through that point here. You all following?
Yes, sir.
All right. And what is the third step now? Oh God. Yeah, what is the third step? Anybody who was paying attention? To shade, correct, David. Very good. Now, in order to shade, we need to label our region in terms of region. Remember, I told you to try to label this one A. Oh God, what doing? Yeah, this one is called A and this one is called B. All right. So since it does not pass through the 0, 0 axis, let's switch to our camera now, and I'll show you how to do working for this. Actually, we can use the shortcut method. I showed you already obtuse angle and instead of doing this working. So let's go to that. Right. So remember I told you to just simply draw a line, a horizontal line, anyway along the curve. Which is the less than region? B or A?
B.
Correct. B is the less than region because this is the side where the acute angle is. This, however, is the side where the obtuse angle is. So the third step is to locate the wanted region by examining the angle between the straight line and any horizontal line, as is the case here. So the region that holds the obtuse angle is the greater than region. You follow? And why are we choosing the greater than region? Anybody can tell me? Yes, David, I see you raise your hand. Nobody tell them why we're using the greater than region? Okay, no problem.
Satisfy the inequality.
Correct, to satisfy the inequality. And as you all can see here, the inequality tells us that y is greater than. So we know we're looking at the greater than region. You follow? That's why we are selecting this region here, A, the greater than region. So in your exam, you would shade here. So you could just take your ruler and just draw some lines, some straight lines to shade it, right? You can remember it's not art class, right? So you're just shading this region here. You're just drawing lines to indicate that you shaded it. Okay, do not cross this line and come down all here because you've lost marks. Do you all have any questions so far? Anybody wants me to explain anything? Say now or forever hold your peace. Sure, what exactly you want me to do about Joshua? Everything or just the shading part? Everything, Joshua? Oh my God. Okay, just now. But do you understand how I got the table of values, the values in the table of values? Okay, great. So that means I don't have to do everything then. Right, so after we establish our table of values, the next step was to plot our graph, right? So suppose this line was not here already. The first set of coordinates was 0, 0 and 4, then 1, 1, then 3, -5. All right? So the point 0.04 would be right here. And then 1, 1, 1 on the x-axis, 1 on the y-axis, that's right here. And of course, 3 on the x-axis, 5 on the y-axis would have been somewhere down here in the bottom, but we don't have graph page for all of that. Okay, so that would have been that. The third step is to determine which region we are shading. Oh gosh, which region we are shading. Now, since the inequality says y is greater than or equal to -3x plus 4, the inequality that we want to the side that will satisfy the inequality will be the greater than region. Now, I told you all, instead of doing the testing method, you can do a easier method where you just draw a horizontal line anyway through the graph. The graph is the black line there. And the side that has the obtuse angle is the greater than region. The obtuse angle is on this side here, right? This is region E, and this is region B, of course. So the side that has the obtuse angle is the greater than region. So obviously, since it's greater than we're looking at, the side that will satisfy this inequality will be this side here, right? So we shade in this side here. I hope you understand now, Joshua. All right. So let's go back to the handout. Right. So solution of a system of inequalities now. Sometimes we may have to identify the common region that is satisfied by more than one equation. Sorry, inequation. In such cases, we draw the graphs and shade each region separately. I'll repeat that again. Sometimes we may have to identify the common region that is satisfied by more than one inequation. So what this is telling us that we can have more than one inequation. So right now we were dealing with only one. In some cases, in fact, in most cases in CXC, they give you more than one inequation. And in such cases, we draw graphs for each of them and we shade each region separately. Now, there must be a region that is satisfied by all of the inequalities, and that is the region that we will be looking at, right? That's the one we will take into consideration because that region will satisfy all of the inequalities. In other words, that will be the common region. You might be lost with what I'm talking about, but not to worry, I'll explain it now. So let's look at the region that is the solution of x is greater than or equal to 2 and y is less than or equal to 3. So let's see how we're doing this. Let me just go back to the Microsoft Paint. Just give me 1 minute, right, people? I'm using my same graph we used just now, just erasing it. Right, are you all seeing the graph here? So
Yes,
the
sir.
region, they are asking us to shade the region that is the solution of x greater than or equal to 2 and y less than or equal to 3. All right, people? So y is greater than or equal to 2. Sorry, x is greater than or equal to 2. That means x includes 2 and value is greater than 2. Agreed or disagreed? You all agree or disagree?
Agree.
You say not like you're not sure, girl.
I'm not sure.
Yes, you are correct. So remember, x is greater than or equal to 2. So if we were to represent this in a number line, 1, 2, it will include 2, and it will, so we're shading it because it is equal to 2 and value is greater than 2. So it will be things like 3, 4, 5, 6, etc. Agreed? Or disagree? Anybody? Somebody? Hello?
Agree.
Agree. Good. Great.
So draw the line in and then demonstrate it. It might be a bit better visual.
Yeah, but that's always demonstrated. Anybody number line first, so they will know that it includes 2 as well. So,
But just
x,
because if you draw it in as a vertical line.
yeah. So x is greater than or equal to 2. So let's locate the line where x will be greater than or equal to 2. Which is the x-axis? The horizontal axis or the vertical axis, people?
Sis,
The one that is like on the flat.
The
flat
the
one
horizontal
on the bottom.
one.
Okay.
The horizontal one.
Miss
Vertical.
Ramatola?
I was kind of understand from the way that you were teaching it before.
Which one? With the number line?
Yeah,
That's why I did a little thing in the side here?
yeah. I prefer
Okay.
that
Yeah, well, right. That's why I did it that way as well, because that will kind of help certain, because not everybody will be able to follow visually what I'm talking about. That's why there's a little work in there on this side as well. So we first have to locate where x is equal to 2 on the x-axis. So that will be over here. This is where 2 will be. As you all can see right here, 2 is right here. You're all seeing me dangling it here. Right, that's where 2 will be. So it's a horizontal, sorry, it's a it's a vertical line. Megan, it's a vertical line. So we're drawing it here. And since x is greater than 2, then which side are we shading? The right-hand side of the line or the left-hand side of the line?
The right-hand side.
The right-hand side, because that will include values greater than 2. Remember, that's when I did the number line here, and I was telling you all that it would have been things like 3, 4, 5, 6. So you're shaded on the side that will show 3, 4, 5, 6, which is this side here. Right? So that will be shading, we'll be shading this side here. Next, let's locate the line for y is greater than 3. So let me just do a little working again here. Y is less than equal to 3, sorry. So we have 0, 1, 2, 3. So that means it includes the values for 3 and less than 3 as well. So it will be to the side where it will be less than 3, which will be 2, 1, 0, etc. Right? So let's see. We locate the line for y is equal to 3. So let me use a different color. Let's use purple. So y is equal to 3 will be here on the y-axis. And if it's less than 3, are we shading the top of the line or the bottom of the line? Anybody?
Underneath of the line?
Yes, correct. The underneath of the line. We are shading the underneath of the line. So let me choose a different color. Yeah, black. So where do you all think the common region will be? Let me just call it. Let me just write letters all over the page. A, we call here A, we call here B, we call here C, we call here D. Which region is the common region? Anybody can tell me? Region A, region B, region C, region D.
D.
D? No, but
D.
nothing from the green line going across by D.
D.
Nope.
C.
Correct, C. So this would have been underneath the line, right? So the common region where the lines would have crossed or intersect when we're shading would have been where? In the region C, which is, let me get different color, let me use yellow, which is this region here. So this region here is the common region. Anybody would like this question redone? Say no.
Yes, sir.
Yeah.
All right, let me do it back then. Okay, so maybe I'll go back to the number line thing again, right? The first thing you have to do is draw the line for x is greater than or equal to 2. So we're looking for 2 on the x-axis, that's right here. Right, that's this 2 here. So we are going to draw a line on the x-axis where x is equal to 2. So that's a vertical line passing through 2. Let me choose a different color, it might be too dark. Right here. So you're all seeing it here, right? And if it's greater than 2, that means it includes values such as 3, 4, 5, 6, 7, etc. So we'll just draw some lines going across here to indicate that this is greater than 2. Any confusions there? Say no.
So I have a question, right? If say x
Yeah.
is greater than or equal to 2. So if it was, since it said equal to, right? No, sorry. If it wasn't saying that it's equal to, how you would have drawn the line?
Drawn the line?
Yeah.
No problem. That's a very good question. So you are saying if x is, if it was just greater than 2?
Yeah, if it was just greater than 2.
Right. Then in that case, you would have drawn a dotted line coming straight down, passing through 2. It would not have been a solid line. If it was not equal, if it was just greater than, then you would have just drawn a broken line like this.
So basically, the broken line indicates that it's not equal to?
The 2, yes, correct. Very good. You're correct. You understand?
Yes, sir. Thank you.
No problem. So let's draw our line now. Let's redraw our line. So we're shading now the region that is satisfying. That's this side. What's that? Behave yourself. Next, we will look at y is less than 3. So we're looking for 3 on the y-axis, which is over here. As you all can see, it's over here, right? So we will draw a line for y is equal to 3. So less than or equal to 3. That means we're shading to the bottom of it here, because it will include things like 2, 1, etc., right? So we're looking for a common region, and we now get into the common region. As you can see, the lines are intersecting where they're shaded, right? So to make life easier for you all, let's label it. I'll call here A, I'll call this side B, I'll call this side C, and I'll call this side D. This whole thing here will be D. Which is the common region, people?
C.
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 C is obviously the common region because that is where the intersection takes place. Okay? Of course, you don't want to label your side, your diagram B and A and whatever. And in the exam, all you are doing is shading the common region. So all this line that I draw here, I have to now go and erase it because you will only be shading the common region. Am I clear?
Yes, sir.
Yes, sir.
Right. You can draw it just to know where you're shading. But in terms of the common region, you have to only shade the common region. Don't go play taking your fast self and shading other places. You have to now rub off the lines that you draw in other places. Otherwise, you're going to end up in trouble. Right? So only the shaded region, the common region will be shaded. If you color this how much, sorry. If you color this how much you want, however you want, once you shade the common region. All right? Any questions so far?
No, sir.
Okay, so let's go back to the handout now. So this would have been what I shaded before with x is greater than 2, right? This is also how it would look if I had drawn, well, when I drew y is less than 3, and when we combine them both together, the orange region here would have represented the common region, okay? So this here would have been the common region, and this is the only region you're shading in your exam. If, of course, you had to do this, okay? So let us look at how we would draw a graph like, let's say, this one. Anybody can tell me? Anybody? Somebody?
Wait, so what was the question?
Just a minute, right? Let me just, look it right there. Shade the region that is satisfied by y is less than 2 and x is less than 3. Y'all want me to do it?
Yes, we do.
Yes, sir.
Well, it's so helpful. Thanks a lot. What a real help in this old man. Okay, so here is your graph here. Oh, what here me is Haz's. Before you see it, you have in front of you a graph, right? David Sharp. So you have a graph here. We want to shade the region that is satisfied by y is less than 2x and x is less than 3. So let's make a note of that on the side so I would not forget it. Because as you all know, I'm getting younger by the day. Y is less
So
than.
you're not even that old.
Thank you very much. First thing you ever say nice to me, Emily. God will richly bless you.
That is so not true. I say so much
You
nice
look
things.
different though.
Where you say, Alicia?
Your looks different though. Say something else.
Alicia? Try your best, eh? Oh God, David, you're not shine me up so? Yes, I'm very forgetful when I'm ready. Okay, so are we drawing a solid line or a broken line? Anybody can tell me?
A broken since is less than or not equal to.
Correct. Exactly. We don't have the equal to sign, so we will be drawing broken lines. So as you all can see with the first one, we have y is less than 2x. We didn't say 2, we said 2x. So that means we have to go and find what is x. Agreed?
Yes, sir.
So this one is not as easy as it looks. So let's go to our table of values because we have to find a table of values now for this one. This one gives me a little pressure. So y is less than 2x. So we will choose about two values for the 2x. We'll choose, let's say, 1 and 0. I just choose 1, no, 0 and 1. It can be 1 and 0. So when x is 0, y will be 0 as well. And when x is 1, y would be 2, because 2 by 1 obviously is 2, right? So we will use the coordinates 0, 0 and 1, 2 to plot our graph. So let's go back to our graph now. So 0, 0 is right here. That's this origin here. Are you all seeing it?
Yeah.
And then when x is 1, y is 2, that's over here. So now we will draw a broken line. Oh God, I did wrong. Of course, you would use a ruler, right? I'm using Microsoft Paint, so mine will obviously not come out properly. Okay, and how do we decide which region is the region of the shading? Anybody want to tell me? I'll give all you $100 one time. I'll transfer it to your account. How do we decide which region is the region of the shading? For a question like this, where find the angle. Very good, David. Hey, you're paying attention, David. Very good. So you have to find the angle for questions like these that are of the form y is equal to mx plus c, where we have an x value. You have to draw a horizontal line. So let's draw the line. And which region we're interested in? The less than region or the greater than region?
Less than.
The less than region. So which region are we looking at? Let's call here A. This now, let's call here A and let's call here B. So which region will satisfy the inequality? Which region will be less than region?
B.
B.
B? No. Look at this here. This is the acute angle.
Well, then A.
Right, and B is the greater than region. And we know we want to look at the less than region because this is the less than sign here. All right.
So wait, just go over back that little piece there.
Sure, no problem. So we draw a horizontal line here, anyway along the line. This side forms the less than region, sorry, the the acute angle, and this side forms the obtuse angle, right? And the obtuse angle is the greater than region, and the acute angle is the less than region. And since it's less than we're dealing with, we were looking at the less than or the acute angle side. So it'll be the side of the acute angle, which is this side here. All right. So now that we know that, obviously, when you're doing that in a pencil, you will erase it if you had to when you was doing it. If you would have had to do a paper 2 exams, you would have used your pencil and rub off all the extra lines when you're determining which side is the acute angle side and so forth. So we will be shading this side. Any confusions? Anybody confused about anything? See now? Right. Okay. So now that we have that down pack, we're looking at now when x is less than 3. So that means we locate 3 on the x-axis and we're drawing a line. What kind of line we drawing? A broken one or a solid one?
A broken.
A broken one.
Correct. Wait, why change color? All right. So less than 3 will be to the left-hand side of the line or the right-hand side?
The left-hand side.
Right-hand side.
Correct, the left-hand side.
Oh.
So let me just erase the extra shading. Yes, it's the left-hand side. So we're shading here. So, and as can you all see the common region then?
Yes, sir.
All right, so this is the common region here. Between the 2 lines is the common region. And this is very easy.
Kinda.
Yeah, it's not that bad. So, do you all want a break now, or you all want a question to try?
A break, please.
Okay, so it's now 2:17. At 2:30, we'll resume class. Is that okay?
So you let Sanjay decide if the class wants a break or not?
Oh, well, nobody else wasn't answering.
We have an option whether we take a break that we leave earlier or anything, or it's just a break.
I thought this class was 1 to 4 on Sundays.
Yeah, but if we finish half an hour earlier, then we'll go.
Oh, okay.
Or you all want to go till 4?
No, we didn't say that. I was just confused about the
So,
time.
then if we finish in 2:30, it's best we just not take a break. I don't know.
Okay, well, that's not a problem then. We will not get any break then, and we go straight until 3:30. That's up to you all. It's fine with me.
Whoa! I didn't say I could go for a break.
Oh.
Tell me you want a break?
Okay, but all you're using Zoom on like
Sanjay
a
already
phone or
took a
devices.
He said it was break.
So at least, okay, well, we'll take a 5 minutes then, and then we'll just come back.
Okay, 5 minutes, right? So it's now 2:19. So we start back at 2:25 on the dot, right? We'll take a 5 minutes breather.
So
Right.
don't forget to stop recording.
Yeah, I'll pause the recording. Never mind. Okay, great. So let us continue then. I'm seeing you all chatting. Let me just see what you all saying.
So don't even bother to read that chat.
Oh my God, Alia.
Sit up on it, just start teaching. No?
Yes, sir, just teach, sir, just teach.
Okay, we're continuing. The break is over. Let's look at this particular question here now. shade and identify the region that is satisfied by y is less than or equal to x plus 4 and y is less than or equal to negative x plus 1. So anybody could tell me how we're going about doing this to start with?
So I guess since they give us x and not a value for x, that we have to find a value for x.
Which we have to do what?
To have the table of values.
Correct. Yes, you are correct. Oh, Lord, I'm not the host. How do I make myself the host? Okay, just a minute. Okay, so the first thing we have to do is construct our table of values, right? So let's first identify the equations, the inequalities, sorry. So x is less than or equal to x plus 4. And then, sorry, y is equal to less than or equal to x plus 4. And then y is less than or equal to negative x plus 1. So the first thing we have to do is, as Alicia said, construct our table of values. We'll just randomly choose any two values. Let's say we choose 0 and negative 4. Again, we'll choose two values here. And I'll choose 0 and 1 as did the book. So now we will do our working for it. When x is equal to 0, we have to find the respective y value. So y is less than or equal to x plus 4. Y is less than or equal to 0 plus 4. Y is less than or equal to 4. So 4 is the first value here. Let's continue. When x is equal to negative 4, y is less than or equal to x plus 4. Y is less than or equal to negative 4 plus 4. Y is less than or equal to negative 4 plus 4 is 0. So 0 goes here. All right? So that was for that one. Let's look at the table of values for this one. So I'm trying to right. So when x is equal to 0 now, y is less than or equal to negative x plus 1. So y is less than or equal to negative and 0 plus 1. But of course, we know 0 is neither positive nor negative. So that just goes to 0. So plus 1, y is less than or equal to 1. So when x is 0, y is 1. I'm just raising this because every time I write here, it's hitting the tripod, right? When x is equal to 1, y is less than or equal to negative x plus 1. Y is less than or equal to negative into 1 plus 1. So this is negative 1 plus 1. Y is less than or equal to 0. Everybody okay with what I have here so far?
Yes, sir.
Okay, I'll leave it up for a minute just for you all to take it down if you need to, because you wouldn't get this in the handout.
So we have past papers to do this.
Oh yeah.
Okay.
I'll send a few questions for you all to try for homework, right? Okay, are you all finished?
Yeah.
All right. Let's switch the screen. Why can't I switch the screen now? All right. So let us plot the graph now. Let's just recall the values, the coordinates for the first graph. Anybody could just quickly tell me what the coordinates are or were for y is less than or equal to x plus 4. What were the coordinates here?
4 and 0.
No, 0 and 4.
No. 0 and -4.
No,
And then
X
what-
was no for the next one. X was -4.
Oh, and this one is 0 and 4, right?
Yeah, this one is X is 0, Y is 4.
Yeah. All right. So let's write the coordinates for the next one time. Y is greater than or equal to. Anyway, let's do it in pieces. Okay. So the first thing you'll want to do is plot your coordinates when x is 0. So it's 0 on the x-axis, that's by the origin here. Y is 4. So that will be this point here. Yes, folks? Next, when x is 0, y is -4. So that will be at this point here. And what kind of line we drawing? A straight line or a broken line?
A broken line.
A broken line, why, Emily?
Because it's greater than or equal to.
Alicia, you were saying a straight line?
A solid line because it's equal to.
Correct. So Emily, only if it was
No,
y.
sir, it's greater than or equal to. It have it right there.
Yeah. So that means we're drawing a straight line, a solid line.
No, that's a broken
Nope.
line.
Nope. Let's just quickly go back to the handout just for me to win that case against Emily.
Emily, once you don't have the equal sign, it's a broken line. But once it have it, then it's a solid line. Well,
Oh, I was mixing that up then.
yeah.
Watch. Look here, Emily. You see it?
Okay, so you're the teacher. You could have just moved on. You didn't have to go back. I
No,
wasn't
because
fighting
remember,
it wrong. I was just saying.
remember, I make mistakes too sometimes, right? But this time, I'm not
Yes.
making a mistake. Look at here. So it's drawn as a broken line.
Okay, I was mixing it up then. Yes, so
Yeah.
you're trying to fight with children.
Me?
David
Never.
said, yes, David said you're trying to fight with children. He never see more.
Me, I will never do that. I don't fight with children. Sure.
The cup.
What?
He say
Well,
lying.
Oh, me, I would never lie. So we're drawing a straight line, right? It must pass through the points. Now let us determine which side of the line we're shading. Now, which region will satisfy the inequality? The less than or the more than? Which region are we looking at? Are we interested in the less than region or the more than region?
The last one.
The less than region, because the equation is y is less than or equal to x plus 4. So let us draw the horizontal line. Let us draw the horizontal line to do the test. So anyway along the line, we draw the horizontal line, right? And the acute angle side will be the less than region. So which side is that? Let's call here A, and let's call here B. Which side am I talking about?
A.
The right side, yes. A. So we shade on the side that says A. So that's underneath the curve, so we can remove all of this. Why is it not coming out? Right. So we're shading on the bottom here. Next, let's do our next curve now. Y is less than or equal to -x plus 1. And our coordinates were what? 0, 1,
And then 1, 0.
1, 0. Right. So let's plot our coordinates now. Right, 0, 1, 0 on the x-axis, 1 on the y-axis. So that's right here. Then 1 on the x-axis, 0 on the y-axis. That's right here. So now we will draw our line that will cut this point here, these 2 points. Right? You don't have any questions so far while I draw there?
No, sir.
All right. Now, how do we determine which region we shade in? Anybody? Find the acute angle. Correct, David. So we draw a straight line. Let me look for a clean side. I'll use it here. We draw a straight line. Which side is the acute angle? Let's call this side here A and this side B. Which side is the acute angle? A or B?
A.
A, correct. A will be the side of the acute angle. So therefore, the common region will be this region here. Right? This whole region here is the common region. So now we could go and draw off the other lines that we draw there before we get ourselves in trouble. Right? So any questions so far?
Yeah, so seeing that we might be, well, we won't be able to draw the graphs or whatever for CXC, right?
Right.
That might bring the question.
That's actually a good question. Who knows, they might actually give you all the setup here, and based on the lines, they will give you all the lines and equations and stuff. And they might possibly ask you they might give you like why doing it in region A, B, C, D, and ask you which will be the shaded region. And option A might be A, option B might be B, option C might be C, and option D might be D. That's a possible way they could bring it, but I highly doubt they will bring it so difficult. Because I was going through the multiple choice papers and I did not see any question on linear programming in the multiple choice, at least in the papers that I have. So you never know if they could bring a new question on linear programming, or they might leave it out entirely on the paper. But like I said, I'm not leaving any stone unturned. I'm teaching everything. The only thing that I will not be teaching, because I know that definitely cannot test it in the multiple choice, although I've seen it in the multiple choice, but in terms of you all actually doing it, is constructions. So I will not be doing constructions with you all, right? But in the multiple choice, if it comes, it will more or less be a repeat question. So those of you who are actually on the exam studies session that we have on a Saturday morning, when we reach the geometry and stuff like that, you will actually see the construction questions there. Okay? So that's why I'm advising you all. It's very important that I'm not telling you all to join the class, but try to at least, see if you could talk to your parents and stuff and see if you could get into the class. I believe it's a paying class, so I'm not sure how much you have to pay, but you have to talk to Lennon about that, right? But it's a class that will definitely benefit you because I'm doing the past papers, the multiple choice papers, and I'm doing it based on topic, just like how I teach, right? So, you have to take a look about that. I'll look at that, sorry. No, David, unfortunately, the session, I'm not doing any paper trees. So, but what you could do is consult FastPass Maths, and you can go through the paper trees on FastPass Maths and see how the questions come, and based on the answers, you will be able to, do your paper 3, possibly. But of course, if you was doing the regular class, like if I had you all on a Saturday, and of course I would have done the paper trees with you, I would have go through some paper 3 questions with you all, right? At least one paper I would have gone through with you guys. But I'm not sure how classes will run. Maybe during a Saturday class, I might go through a paper 3 with you all if I finish on time, right? But try not to worry too much about it because the paper 3 is not too difficult. Once you go on FastPass Maths, Fayad explained the paper 3 quite well. So it's not like you just put the answers there. He has the working and everything. And remember, I'm using the notes that is on his website, right? So it will kind of it will work in tandem with the past paper solution. So you don't have to worry too much. It will not be anything that you will not have been familiar with. I would have been using the jargons and the language that you would be seeing in the paper 3. So not to worry too much about that, right? So let's continue with the note. We just have a little bit again to finish and we're done. All right, let me just get back to the handout. All right, so this is what the graph would have looked like. This is the shaded region here, as you all can see, and that's exactly what I did. All right. Yeah, Joshua, I'm seeing your messaging. What's up? You sure? All right. So, Alicia, this is how they could possibly ask you a question, right? They could give you this, and they could have the options describing the shaded region. You follow? They could give you a graph like this, and you will be asked to describe the region that is shaded. Yeah?
Okay.
So the easiest one to figure out so far is which line here. The two slanted lines or the horizontal line, which is easier one to recognize. We have 1, 2, 3 lines drawn there. Let me zoom up a little bit so you can see it.
So the two slanted lines?
No, those are actually two difficult ones to figure out. A horizontal line, a flat horizontal line, or a straight vertical line is always easier to read off. Are you seeing a straight vertical line coming down anyway here? Anybody? Okay, let me transfer this information to Paint and we'll do it from scratch. Okay, what you all are I am seeing here, the easiest one is this line here. Let me reconstruct the line so you all can be able to see it better. Are you all seeing this green line here?
Yes, sir.
Right. So what is the equation of that particular line? Which axis is it passing through? The y-axis or the x-axis?
The y-axis.
Right.
Yeah.
So y is equal to what?
-2.
Correct. So we found the equation of that particular line to be y is equal to -2. Now, let's look in terms of an inequality now. Which region does it satisfy? Y is greater than -2 or y is less than -2?
Y is greater than -2?
Greater than -2, correct. Because greater than -2, remember, values greater than -2 will be things like -1, 0, +1, +2, +3 going this way. And as you all can see, it's going this way, right? In terms of the shading region. So y is greater than or equal to -2. So we know we have that down pat already. Yeah?
Okay. Yes, sir.
Right. So now let's go back to the handout and I'll be able to explain stuff further to you all. Let's look at the solution. So we already know how we get that -2 here. Okay? For the line y is equal to -x, the shaded area lies in the region with the acute angle. This region is therefore y is less than -x. Right? Let's see y is equal to -x here. You all can see it there, right? And then of course, y is less than, this is the y is equal to negative x here, right? This line here, sorry. Okay, it passes through the origin here. This is the line y is equal to negative x. So, and of course, okay, let me show you all that in the paint. So the line y is equal to negative x. That'll be this red line here coming down, right? And of course, as you can see, it's to the bottom here we're shading, right? So it's less than. You follow? So that means that y is equal to negative x. So y is less than or equal to negative x, because as you can see, that's a solid line. Y'all following?
Yes, sir.
Right? So let me just make something real clear. Just a minute. Control N. New. Control V. Right. Suppose we have a Cartesian plane here. Obviously, you all know this is the x-axis. And this is the y-axis, right? If we have a line that passes through the origin like this, the equation of that line is y is equal to x. If it is going in that direction, right? If, however, it is going in this direction, it is y is equal to negative x. But it has to pass through the origin here. Yeah?
Yes, sir.
So that's how I know this particular line here is y is equal to negative x. Understood?
Yes.
That's why you're following? All right. So let's go back to the handout now. And for the line y is equal to x plus 2, the shaded region lies in, the shaded area lies in the region with the acute angle. So this region is therefore y is less than or equal to x plus 2. So that's how I got my 3 inequalities there. Now a question that, a type of problem that they love to bring in CSEC, if you have to write paper 2, is converting worded problems into linear inequalities. Now I can remember very clearly, I had loved this topic when I was in CXC, and because I like it so much, I thought I was really good at it, and I did not even bother to revise it. And this particular question was the question that was the only question in that paper that gave me trouble, and it was a worded problem, linear inequality, and I'll never forget it. So let's look at this. So, like I said, people don't think you know everything in the syllabus. Go through everything, and I can tell you from personal experience, do not leave any stone unturned. Do not think you understand this, and because you understand it, you bypass it. That was the mistake I made, right? And I don't want you all making the same mistake. So please try to study everything, because you do not know, worse yet, we do not know how the exam is going to come. We know it's multiple choice, yes, but we do not know how CXC will structure the questions. We do not, in terms of what topics they'll be testing and stuff like that, if it's just a regular multiple choice, because some topics are not tested in multiple choice, right? They're not usually tested, so you never know if they can bring it. So you never know if you will see a linear programming question on your exam paper, okay? And you never know if it might be a worded problem one, and they might ask you which one of these represent the worded problem. You follow? Just now we'll see a table. They can ask you it like this, but you're all supposed to be familiar with it in terms of, yeah, the whole thing is going to be multiple choice, Joshua, except the paper 3. You all don't have an SBA to do, so you all will have to do a paper 3. I'm not sure if you have an SBA already, but if you have an SBA, then you do not have to write a paper 3. But the private students will have to write a paper 3. Okay, so let's do converting worded problems into linear inequalities. Now, we would have done problems like this. Yeah.
We had to do our paper three.
No, Tom, you have a SBA.
Oh, okay.
Yeah, and you did quite well in your SBA too, so you shouldn't have to be worrying about that. Your chance of getting a grade 1 in maths is very high. Those who have good marks in the SBA, your chance of passing mathematics with a grade 1 is very, very high. Especially if you all are coming to the exam session on the Saturday as well, where I'm actually doing the multiple choice papers, and you all are actually doing well in that class, then your chance of getting a grade 1 is without a doubt, right? So please try to study, and I will try to send you all, after I'm finished with this online study session, I'll try to send you all some paper ones to practice with, and I'll send you all the answers as well. So yeah. What paper are you talking about, Alicia? Oh, I'm not too sure about that, but I don't want to talk too much about that because I don't really know too much, and I don't like to say things that I don't really know. But I know for sure, I don't know how the paper going to come. I know that for sure, so that's why I say I teach it all like if I don't know what coming. So that's why I'm doing everything possible. But with respect to the wooded problems, which is the last thing for us to finish this class, the wooded problems, linear inequalities, you would have touched on it a little bit when we did inequalities, when I taught you all inequalities, when we did algebra. We did converting wooded problems into inequalities. You can remember that?
Yeah, sir.
Right. So it's just like that. It's going to be the exact same thing we're going to be doing, right? Converting wooded problems into inequalities, and those inequalities will be graphing those, more or less, right? This is nothing difficult. It's just building on the knowledge on graphs, coordinate geometry, as well as inequalities, right? That's why I taught those topics long in advance, and I spent a great amount of time doing it, drilling past papers, etc. So when we come to this particular topic, we will not have any difficulties or anything of the sort. So let's see. Converting wooded problems into linear inequalities. Sometimes a question may require us to convert a wooded statement into a linear inequality. In writing inequalities, it is convenient to have y on the left side of an inequality. This makes it easier to draw the lines when solving the linear programming problem. So consider the wooded consider the wooded statements in the table below and their corresponding inequalities. So let's look at these here. Just a minute. Just give me a minute. We will translate these together one by one. All right, first question. Anybody wants to help me translate? The number X of roses in a bouquet must be less than twice the number of Y lilies. Anybody?
X.
Uh-huh.
X is
Less than.
greater than 2y.
Let's see. The number X of roses in a bouquet must be less than twice the number.
Wait, I don't know why I say greater than. I mean less than. I read it less than and I say greater than.
Right, so less than 2y. Anybody disagrees with what I wrote there just now? Okay, so now we want to make y the subject of the formula. So let's, for simplicity's sake, just now, x less than 2y. For simplicity's sake, Let's write it the other way around. So we know that x is less than 2y, which means that 2y is greater than x. You all agree?
Yes, sir.
Right? If x is less than 2y, then 2y is greater than x. So we want to make y the subject of the formula, because remember I told you all, you always want to try to make the y the subject of the formula, right? So we take 2, carry it across, we get y is greater than x over 2. And that's it. You all have any questions?
No, sir.
So let's see. The number of the number C of cars that pass on a certain road is at least twice the number T of trucks that pass the same road. How are we doing that?
C is greater than or equal to 2t.
C is greater than or equal to 2T.
2t.
Correct. Yeah?
Yep.
Let's look at the third one. In a mixture of ice cream, the number S grams of sugar must not be more than the number C grams of coconut powder. How are we writing that?
S is less than or equal to C.
Very good. Yes. Let's look at the other questions. In a parking lot, the number of spaces C allocated for cars must not be less than the number B spaces allotted for vans. How are we doing that?
C is less than or equal to B.
T, where do you get T from?
B. C
Oh,
is
B.
less than or equal to B.
C is less than or equal to B. Let's see. In a parking lot, the number of spaces C for allocated for cars must not be less than the number of spaces
Oh,
for
wait, so it's
cars.
greater than or equal to B.
Yes, yes. All right. In a motel, the number L of large rooms must be at least the same as the number S of the number of small rooms.
L is less than or equal to S.
Let's read that again. So you're saying L is less than or equal to S, right? In a motel, the number L of large rooms must be at least means what?
Greater than or equal to S.
Yes. Because if I tell you all, you must get at least 50% to pass. That means you must get 50% or more.
Or more.
It means greater than or equal to, right?
Yeah.
Right. Last question here. In the intake of new recruits in the intake of new recruits of cadets, the number M of males must not be more than twice the number F of females. How are we writing that?
M is less than or equal to 2F.
Yes, M is less than or equal to 2F.
2F.
Correct. Any questions so far before I move on?
No, sir.
All right, let's go back to the handout now. Right. So linear programming. The general process for solving linear programming exercises is to graph inequalities, and the inequalities are often called constraints, right? And we have to identify the region on the Cartesian plane that satisfies all the constraints, which is called the feasibility region. Now you all should know what I'm talking about. Yeah? So you are given a set of inequalities. We graph it, and of course the inequalities are called the constraints. We graph it, and then we identify the common region. Yeah? Yes, people?
Yes, sir.
And that common region there that satisfies all of the constraints, we call it the feasibility region. Now, having identified the region containing all possible solutions, we may now wish to find out what pair of x and y values will lead to maximum or minimum profits, providing that you have a question that involves you finding profits, etc., right? The equation that is used to represent the profit is called the profit or optimization equation. The fundamental theorem of linear programming gives us a law that is useful in determining maximum or minimum values of this profit equation that I'm talking about. We will now present this law. The fundamental theorem of linear programming. So it has been proven that for a system of linear inequalities, the maximum and minimum values of the profit or optimization equation will always be on the corners or the vertices of the feasibility region, which is basically the region that satisfies all of the inequalities. That is the region of the shading I'm talking about here, right? So the coordinates of the corners of the feasibility region are identified, and each corner point is tested in the equation for which we are trying to find the highest or lowest value. So the three inequalities are constraints. The area of the plane that is satisfied by all three inequalities is now the feasibility region. So let me just explain quickly what that is saying here. So we have our feasibility region here. That point is talking about the corners of the feasibility region. So like this corner here, this corner here, this corner here. Any questions?
No, sir.
All right. Somebody messaged on the chat. What did they say?
They said no, sir.
Oh, okay, all right. Okay, so let us look at a quick summary of what you would have learned today, right? So a summary of the steps in solving a linear programming problem. Once you understand today's lesson, all you basically have to do is learn of these 6 steps, right? So you have to read the constraints and write down the system of linear inequalities. So in other words, you're just reading it and you're writing down the inequalities that you would have been given. Obviously, you know, you have to construct a table of values, etc. And the second step is to sketch the system of linear inequalities to obtain the feasible region. You all remember that? So we given our inequalities, we do a table of values, then we sketch the values, we sketch the graph, we draw a horizontal line to determine the obtuse angle and the acute angle, and determine which side we're shading based on the inequality that we are given, right? And then in the third step, we identify each corner point of the feasible region. And of course, number 4, we obtain the profit equation. It is usually in the form Z is equal to AX plus BY. Now, you don't have to worry too much about this part because it's hardly ever tested. Number 5, substitute each corner point of the feasible region into the equation, into the profit equation. And number 6, choose the point yielding the largest value or smallest value depending on whether the problem is a maximization or minimization problem. This is called the optimal solution. Okay, so let us look at a question. Oh, I have no idea, Emily. So I'm going to give you all this question in particular to do for me. I want you all to tell me what the inequalities will be. Let me just transfer this to Microsoft Paint.
I used my iPad to be in class and it just started making this noise and the whole app just closed off.
Oh,
and I get
that's
shut
why
out
you
the
don't
class.
use. That's why just now. Huh?
That's
why you don't use Apple
I'm
product.
not even gonna listen to what you said it.
Yeah. I don't believe in Apple products, so hard luck there. I'm not feeling sorry.
Yes,
Because I did
It
tell
was
you.
made in China.
I did tell you a long time ago. Don't use any Apple products.
I'm not listening to anything you're saying right there. So
My
You know why?
iPad is
Because
you're talking to nobody. You're talking to the
because
screen. You're talking to the
you
wall.
know, Apple Apple is rotten, and just like how Apple is rotten, Apple products just give real trouble. You know.
And I will never ever switch. Never. Ever.
You see, like everybody in agreement with me. Android, though.
Yeah,
rotten,
because everybody have an Android. None of them have an iPhone.
because nobody wants iPhones.
Yeah, I'm sure nobody wants one. Anyway, let's do the question.
So yeah, you all go ahead and continue the question. No, Bala. Apple is not greater than. You see, Emily agree with me. She say exactly.
I never say exactly to you.
Cheyenne, you taking them side here?
Exactly. Cheyenne is on my side.
Thank you,
You know
Sandra.
what? Sanjay and I are not even actually related. I'm sure he like adopted or something. I don't even know him. He's just living in this house. We don't associate with each other.
Okay, so in 5 minutes, I'll be asking you all for answers for this, right?
So we do the question.
Oh God, sorry. I just put a dollar sign Emily and a H and an apostrophe. Sorry, exclamation
So
mark.
I don't want to hear it.
Exactly. I said.
I don't want to hear it. If it was in class, I'd have tell you talk to my hand, but I can't show you my hand right now.
Yeah. Oh gosh, I forgot to take a roll. Way boy. Let me take a roll while earlier. And some people leave us, so that's them. Them will be absent.
So
Uh-huh.
Android have better symbols than Apple.
Hmm. I agree.
Can we join the graph?
Of course, if you could. How are you all getting through?
We waiting the answer.
Yes, sir.
What about you, Leandre? Just making sure you're all okay. Musa, goodbye. Newton, how are you? Reagan, you there? Rennie, what about you? Ramisa, you good, girl? Okay, so by now you all should have some stuff ready for me.
Yeah, I was trying to type it, but I have a less than or equal to sign in the chat.
Probably because you're using an Apple product.
Yeah, you know what? And also, so Sanjay
So I
can't,
just told you that.
Sanjay can't tell you anything because Sanjay have a little Android phone, and every time he wants to call somebody, he's be taking my Apple devices to do so. So he can say all he wants. He's want to use my thing.
Yeah, because I have to FaceTime my cousin.
And if he had an Apple device, he wouldn't have to take it. Anyway, let's answer the question.
Yeah, let's answer this question and then we'll end class there, right? Okay, so let's see here. Natasha wishes to buy X oranges and Y mangoes. So the first thing you will want to do is say, let X equal oranges and Y equal mangoes. By the way, as we're on the topic of mangoes, a special good evening to anybody that starts mango tree.
So even if we had one, how we will sell it for you?
True, true. So let's see. Her bag can only hold 6 fruits. So she must buy at least.
So we could say what we have.
Yeah, go ahead now.
X plus Y is less than or equal to 6.
And what do you mean by that?
Oranges and mangoes could only be less than or equal to 6.
Right, correct. So X plus Y must be less than or equal to 6 because the question tells us that her bag can only hold 6 fruits. So the number of oranges and apples, sorry, the number of oranges, you hear me talking about apple now. The number of oranges and mangoes must not exceed 6. So X plus Y is less than or equal to 6. All right, that's the first equation. The next one, she must buy at least 2 mangoes. At least means what?
Greater than or equal to 2.
Correct. So greater than or equal to 2. And mangoes we're talking about, so it's Y, right? Yeah?
Yes, sir.
Next equation. The number of mangoes is less than or equal to twice the number of oranges. So the number of mangoes must be less than or equal to twice the number of oranges. Did you all have those 3 equations?
Yeah.
Okay. So the easiest equation, sorry, the easiest line to draw there will be this one. So you will look for where Y on your graph, you have 1, 2. You'll have where Y is equal to 2. You're drawing a straight line here, right? And Y is greater than, sorry, Y is less than or equal to 2. So that means we shade in where? Y is greater than or equal to 2. So we shade up on the top here, right? That's the first line we could draw. Everybody good? The
Yes, sir.
next easier one is this one here. So for this one, we can do a table of values. So we have our X coordinate and our Y coordinate. So we choose any random values of X. Let's say I would choose 0, and let's say I choose 2. So when X is 0, 2 by 0 is 0, so Y will be 0. When X is 2, 2 by 2 is 4. Yeah? So 0, 0 will be this point here. And of course, 2, 4, 2 on the x-axis, which will be somewhere here. And 4 will be somewhere up here. Right? So 2, 4 will be here, somewhere there. So we draw a line coming down here. Now, we need to know which is the region we want. Agreed? So the region that we want, how we will know that is draw a line. This is the side with the acute angle. So this is the less than region. And this is the side of with the obtuse angle. So this is the more than region. And since the question here is telling us it's the less than region we're looking at, which side are we looking at? The right hand side or the left hand side?
The left hand side.
As in over here?
Yes.
No, because look at where the obtuse, this is the obtuse angle here. And this is the acute angle. So it's the side with the, it's the acute angle side because this is the less than region. So, and it's less than we're looking at here, right? So, let's erase this line here. So we know it's this side we're looking at here. So far we could already see some lines intersecting here, right? This is so far the common region here so far. Okay?
Yes, sir.
So you can take off some of these lines here. Right? Of course, I'll show you all it on a proper graph after, okay? And then the next one, X plus Y is less than 6. So let's just choose any random values for X and Y, and we need to ensure that it is less than 6. So let's say 0 and 1. So when X is 0 and Y is 1. So X is 0, Y is 1, that's this point here. Let's say when X is 5 and y is 1. So when x is 5, y is 1. That's somewhere here. Actually, no, I'm doing it wrong. Sorry.
No, sir, and to be on the bottom.
Yeah. When x is 5, y is 1. So this line will come down somewhere around here. I'm just sketching it, right? If we were to draw it, and obviously it's the less than region. So if we were to draw something here, then the less than region will be satisfied in this little triangle here because it will come down here. This is the less than region here. So we're looking at this side here, right? So this little piece here is the common region here, right? So we could erase all of this here. Let me just show you all it professionally, how it will be done. Now, when I say professionally, I mean on the graph. Yeah? Let's see it there.
Yep.
Do you have any questions there so far?
No.
Okay. So let's look at the final part of the question. It says that Natasha makes a profit of $1 on an orange and a profit of $2 on a mango. We are asked to calculate her maximum profit and her minimum profit. So anybody can tell me how we're doing that? Anybody? Okay. Let me go back to Microsoft Paint, right? We'll do it on Paint. This will require us to know the linear programming, the theorem I was talking about. The theorem of linear programming. Do you remember I was talking about that?
Yeah.
Yeah, that's the one we're going to be utilizing, okay? All right. Let me zoom up a little bit. Anybody can tell me the coordinates for A? What are the coordinates for A?
2 and 4.
Correct. 2 on the x-axis, 4 on the y-axis. What are the coordinates for B?
One and 2. Wait, yeah, 1 and 2.
Yes. And for
The
C?
C is 4 and 2.
Yes. Okay. Anybody do not understand how I got those? Say no.
The line in the middle was confusing me first because like I thought that was the start and then I realized it wasn't.
Okay. Joshua, now see a message there. So we were looking at the coordinates. To use the linear programming theorem, you have to use the coordinates of the feasibility region here. So we have 3 points in the feasible region, A, B, and C. We have to find the coordinates of A. So the x value for A, let me just draw a line here to show you all how I got the x value. The x value is 2, it's coming down to 2, and the y value is 4. Remember, x always goes first. So 2, 4. That's how I got the values for A. Next, we have to find the values for B. The x coordinate is 1, the y coordinate is 2. So the coordinates will be 1, 2. Next, it's C. So the x coordinate for C will be 4. The y coordinate for C will be 2. So 4, 2. Understand?
Yes, sir.
Right. So let us now look at using the theorem. How we will be using the theorem. So it says here that she makes a profit of $1 on an orange and $2 on a mango, right? So to obtain the maximum profit, we apply the theorem of linear programming, which is what we just did, and test the vertices of the region. So oranges will be X. Oh God, what are we doing? Oranges will be X dollars, well, $1 profit she making on orange, and $2 profit just now. $1 on an orange and $2 on a mango. Agreed? So these are the, let's test A. The coordinates for A is 2, 4. So when X is 2, this is the coordinates, and this is the equation here I'm going to use, right? X plus 2y. So X is 2 in this case, plus 2, and the value of y in this case is 4. So 2 plus 4 by 2 is 8. So this answer is 10. So how much profit she making in this region here? A is $10 profit. Agreed? Anybody confused?
Yes, sir. No, sir.
All right. B, the coordinates for B will be 1, 2. So let's utilize our equation again, this equation here, X plus 2y. X in this case is 1 plus 2, and y in this case is 2. So 1 plus 2 by 2 is 4. This will give us 5. So B is $5. Profit, of course. Yeah? Let's look at
Yes,
point
sir.
C now. Let's look at point C. C is 4, 2. So our equation is X plus 2y, and X in this case is 4, plus 2 by y is 2. So 4 plus 4, which is $8. So of course that's C, right? Yeah? So
Yes,
the
sir.
maximum profit that she can make if she sells 2 oranges and 4 mangoes is how much? What's the maximum profit?
$10.
$10, correct. That's this $10 here. And what is the minimum profit she can make if she sells 1 orange and 2 mangoes?
$5.
$5, correct. Yeah?
Yep.
Any questions for today's
No,
class?
sir.
No, sir.
Yes, sir.
Well, we have come to the end of this session, and we have also come to the end of linear programming. So seeing that you all don't have any questions, I will end the class here. Please remember that you all have class tomorrow morning for 9 o'clock sharp. Please be logged on 10 minutes earlier because I'm starting on time. Because tomorrow we are going to be looking at trigonometry, and that's a very tricky topic as well. So I need to make sure that you all are, that I have the full 3 hours because I need to finish the syllabus. So I am not going to be waiting on anybody, right? So try to be here, to be online at least 10 minutes earlier. So when I log in, I'm starting 9 o'clock on the dot. Okay?
Okay, sir.
You all have a great Sunday evening, and I will see you all tomorrow again. That is the Monday students, of course.
You too. Bye.
Bye.